In this video, we're going to look at dimensional analysis. So what is dimensional analysis? So if we're given a value in non-SI units, we want to be able to convert between the units. So basically, we want to take the ability to weigh something out, such as a sample. If we have 12 grams, we could convert that to kilograms, or we could convert that to ounces. And so we can take any given value and convert it to any other value that we're interested in. A really key point here is that conversion factors have infinite significant digits. They do not control the number of sig figs. In the answer. I like to think of these as just intermediate steps, and what controls the answer is the measurement that you've taken. So dimensional analysis. Dimensional analysis is the ability to go from any given unit, we're going to put green in this case, and then we want to convert to a desired unit. So we're going to use something called a conversion factor in order to do that. And so conversion factors are typically provided. I don't want to say 100% of the time, but conversion factors like this are provided. I will try to always have them in the slides, but sometimes I forget. Sometimes we get them in other places. So the question asks, how many centimeters are in 8.5 inches? If we know that 1 inch is 2.54 centimeters. So we're going to take our 8.50 inches, and we are going to use a product, or we're going to use basically multiplication, and set it up that 1.00 inches is equal to 2.54 centimeters. Now you'll notice that I wrote these as a fraction. So you can do that at any time. And so when you plug this into your calculator, the answer that you should get is 21.6 centimeters. So in this case, this was a relatively simple dimensional analysis. We took one unit and we were able to convert it to something else. So let's look at another example. So if you have a mass of 115 pounds, what about if your mass is in grams? Okay, well this could work. So we're going to take our 115 pounds and we're going to use the dimensions that we were provided, that 1 pound is equal to 453.6 grams. When we plug this into our calculator, we get 5.22 times 10 to the 4th grams. Now, I've already trimmed that number back. When you plugged it in, you should have seen a lot more digits, and so that's okay. But the important part here is that we want to start to think about the ability to make these type of things. So this green square, in this case, is our conversion factor, and so we can always put them on top of a dividing line, and we can start to multiply across. So those are relatively simple. A lot of those conversions you can often do in your head. It's kind of easy, you multiply and divide. But as we move further in Gen Chem 1, we're going to start to use multiple conversion factors. What does that mean? We are going to go from unit A, then we're going to go to A times B, and then we're going to go into B times D, and we're going to have an answer in D. So we will have converted A to D using multiple conversion factors. So I like to think about this like driving. If you're leaving Jacksonville and you want to go to Washington, D.C., ordinarily you would get on 95 and drive north. It is not incorrect to go through Miami, come back up the other side of Florida, go through Tampa, and then come back go through Atlanta, and eventually get to Washington, D.C. You may have taken extra stops. Those extra stops are not bad. They are just not always required. So in this case, we want to look at the 100-meter dash in the Olympics. So how many inches is this? So we're going to take our 100 meters, and the unit conversion provided is in centimeters, which means that we need to convert. So in 1 meter, there are 100 centimeters, and there are 2.54 centimeters in 1 inch. And so when we plug this into our calculator, we should get 3,937 inches, which there are 4 significant figures, so that answer is correct. Now, you might be asking yourself, where did this value come from? And that's okay, because this value is one of the prefixes. So we talked about this in, I think, 1.5, where we want to try to remember that 1 centimeter is, or 1 centi is 1/100th of something. And so in this case, you do need to know how to use those. Ooh, so another example. So the average speed of a nitrogen atom in air at 25 degrees Celsius is 515 meters per second. How fast are we going in miles per hour? So when we start to look at this, it's a lot more things happening. So we have our 515 meters in 1 second. So you'll notice that I've separated this out to, instead of just saying meters per second, I said in 1 second. So this allows me to be able to convert the units. So the trick is, students often ask, well, which one do I convert first? You may choose either one. There are a couple of different ways you could set this up. I will talk you through both of them, but really only show you one. So I'm going to convert the meters first. So we can see that the miles to kilometers our meters needs to go to kilometer. So there are 1,000 meters in 1 kilometer. So from here, we know that there's 1.6093 kilometers in 1 mile. So if we were to go through and cancel our units, which I always recommend, we now have miles per second. But the answer would like to be in miles per hour. So there are 60 seconds in 1 minute. There are also 60 seconds. Nope, there are 60 minutes, sorry about that, in 1 hour. So when you plug this into your calculator, you should get 1.15 times 10 to the third miles per hour. Now, you may be like, so how do I enter this in my calculator? Okay, so in your calculator, my suggestion would be to basically only do, if you can kind of see the blue line, what's above the blue line and then what's below the blue line. So you should put into your calculator, open parentheses, 515 multiplied by 1, multiplied by 1, multiplied by 60, multiplied by 60, divided by, open parentheses, 1, times 1,000, times 1.6093, times 1, times 1. You should get the exact same answer. Oops, sorry, got things a little off. So you can set it up that way. You can, I've also seen a lot of students who really like to set it up as 2 different things. So they'll take their 515 meters and convert that separately. So there are 1,000 meters in 1 kilometer multiplied by, or divided by 1.6093 kilometers in 1 mile. And then they take their 1 second times 60 seconds in 1 minute times 1 minute, 60 minutes and 1 hour. And then they divide these two values. Both of these ways will work. You will get the same answer. So if you're having problems, feel free to pause at any point in the video and go ahead and work the problem and see if you get the same answer. You're welcome to try to pause before we get there, after, anywhere in between. So unit conversions using density. Density is the thing we talked about before where it talks about mass per volume. We can use density to calculate other things. So if we have a cube of silver that is 2 inches cubed, what is the mass of the cube if the density is 1 gram per cubic centimeter? So we need to convert 2.00 inches cubes into centimeters cubed. So there's not a conversion factor here. So 1 inch equals 2.54 cubic centimeters. So we're going to use that information. So we're going to take our 2.00 inches cubed and we're going to convert it. So we're going to take 1 inch cubed and 2.54. Whoops. .54 centimeters, and then we're going to cube it. So the cube on the conversion factor was incorrect. So you'll notice that I put the 2.54 right here. It's inside the parentheses. So why is that? Because the conversion factor needs to be cubed. So a 1 inch cube is equal to 2.54 inches cubed. So it is in fact that we multiply 2.54 times 3 times. So then we can plug this in and we get 32.8 cubic centimeters. So it's always important in this case, there should be a couple of ALEKS objectives to help with that. So we're going to take our 32.8 cubic centimeters and multiply that by the 10.49 grams in 1 cubic centimeter. And so now our units will cancel out, and then we will get an answer of 343.8 grams, and then we need to use our significant figures. And so in this case, it's going to give us 344 grams. So we can use density in a unit conversion, or a unit conversion in density. So another example. In this case, an international barrel of oil in the current market is equal to 1.33 US barrels of oil. Currently, the price of oil is $48.52 per international barrel. Also, that is not the current as of the recording, it's the current when I wrote the question. So what is the price in dollars per gallon if 1 US barrel is 31.5 gallons? So we're going to take our $48.52 per international barrel. And now we're going to convert from international barrels to US barrels. So 1 international barrel is 1.33 US barrels. And we know that 1 US barrel is 31.5 gallons. So all we've done is set up a series of multiplications, and in this case, we get the dollars per gallon is going to be 1.15526, and we need to think about our significant figures. The number of gallons will alter that, and so this will be $1.16 per gallon. So in our next example, we're going to use density again. So the recipe for honey soy chicken calls for 63.9 grams of honey. You've opened your cabinet. Honey is in fact a liquid. So you could use a scale and weigh it out, but I'll be honest, I personally don't own a scale in my kitchen. But we can use our unit conversion tools in order to determine how many tablespoons of honey is this recipe calling for. So we are provided the following information. The density of honey is 1.42 grams per mil, and 1 tablespoon is 14.78 milliliters. So we're going to take our 63.9 grams of honey, and then we're going to use the density. Then we're going to use the density of honey, which is 1.42 grams in 1 milliliter. So if we use our units, that gets rid of grams. Then we're going to convert into tablespoons. So there are 14.78 milliliters in 1 tablespoon. When we plug this into our calculator, we get that there are 3.04 tablespoons of honey required to create honey soy chicken.